All right, let's talk about the real-world applications for graphing quadratic functions. So problem number 1. Of course, real-world problems means word problems. So problem number 1 is talking about trajectories, and what we want to do is read through the problem very carefully and highlight key information. So, a cannonball is launched from a cannon on the wall of Fort Chambly, hopefully I'm pronouncing that right, Quebec. If the path of the cannonball is traced on a piece of graph paper, aligned so that the cannon is situated on the y-axis. So this is a key piece of information, that the cannon is situated on the y-axis. The equation that describes this path is this equation right here. We're going to highlight that because that's important. Where x is the horizontal distance from the cliff. All right, so x is the horizontal distance from the cliff, and y is the vertical distance above the ground in feet. How high above the ground is the cannon? All right, so what we want to do is we want to visualize this. So we have a picture. Let's use this picture. We know that the cannon is situated on the y-axis. So what we want to do is think of this as our y-axis. All right, and x is the horizontal distance from the cliff. So we know that our x-axis is definitely going to be the ground. All right, so this is how we want to visualize our cannon on the cliff above the ground. Now, we can visualize our cannon at this point right here on the y-axis. So we know that if we were to describe this point as an ordered pair, it would be 0, comma, whatever y is, right? So x is going to be 0, and we don't know what y is. That's what we're trying to find. How high above the ground is the cannon? So what we're looking for is that y value. So what we want to do is we're given a quadratic equation that's describing the trajectory of the cannon. All right, so what we want to do is we want to solve for y when x equals 0. So we plug 0 in for x into the quadratic equation we're given. So y is what we're looking for, equals negative 1 over 1600, and x is 0 squared plus 1/2 times 0 plus 20. All right, now 0 squared is going to give us 0. And then anything times 0 is just 0. So if we keep going with this, negative 1 over 1600 times 0 is 0. So 0 plus 0 plus 20, y equals 20. So that's what we're trying to find. The y that we just found is this y right here, and that's how high the cannon is above the ground. So we can say that the cannon is 20 feet above ground. And that's our final answer. All right, number 2. Let's read through the problem and highlight key information. So, ticketing. The manager of a symphony computes that the symphony will earn negative 40p squared plus 1100p dollars per concert if they charge p dollars for tickets. What ticket price should the symphony charge in order to maximize its profits? All right, so first off, the key information we get from the yellow highlighted information is that we have a quadratic function here. So, oops, I don't want the highlighter anymore, I want my pen. So if we're saying the function is f of p, because it's not f of x, we're talking about p dollars for tickets, f of p equals negative 40 p squared plus 1100 p. So there's the quadratic function that we're going to be dealing with. All right, now we have this keyword here, maximize its profit. And we know the maximum of a quadratic function, right? If we have a quadratic function that looks like this, the maximum is going to be the vertex up here, right? So what we're looking for is we're looking for the vertex if we're trying to maximize the profit. Because what we want to know, this is our p, right? And this is our f of p. So we want to know what is f of p, what is this value when p is at its maximum, right? When this is our p. So we're looking for that vertex, and we know that we have an equation to help us find the axis of symmetry, which will help us find the x value or the p value of the vertex, right? So our axis of symmetry is negative b over 2a. If we find the axis of symmetry, we're going to find that x value or that p-value. We're going to find that p-value for the maximum or for the vertex. So all we've got to do is find the axis of symmetry. So we know our b is going to be 1100 and our a is negative 40. So we're plugging that in. So negative 1100 over 2 times negative 40. So we get negative 1100 over negative 80. And if we plug that into our calculator, we're going to get 13.75. All right, now putting it back into the context of the problem, this is our P equals, right? This is our axis of symmetry right here. So that's what we're looking for. We're looking for the X value or the P value, the price in dollars for tickets. That's going to give us the maximum profit, right? Because our profit is the Y. So the ticket price needs to be $13.75 to get our maximum profit. And that's our final answer. All right, if you have any questions about word problems, aka real-world applications of graphing quadratics, please raise your hand, call me over and ask. Otherwise, look to the board to see what to do next, and hope that you have a great day. Bye.